This is part one of the crude oil and fuels topic. It's GCSE AQA chemistry and it's dual and triple award. So anybody taking AQA chemistry at GCSE will need to look at this. In this first video, we're going to look at hydrocarbons. We need to know about where crude oil comes from, what alkanes are. We're going to look at chemical and display formula of alkanes, and we're also going to look at how we draw and name them. So the first information that we've got here is about how crude oil is formed. There's a big paragraph that you can take the time to read. I'm going to pick out some of the key bits. Now, the first thing is the time scale. It is a very slow process. It takes place over millions of years. It's important that you remember that. It's also at very high pressure. We've got layers of sediment building up on top, adding to the pressure, compressing down on the materials that become crude oil. And it's in the absence of oxygen, so we don't get the normal decomposition and breakdown of living things that we might always expect. And it is tiny plants and animals in the sea that were died and buried in the mud that went through this process to become crude oil. So, a couple of questions for you. Have a think about these and unpause when you're ready. So when we talk about crude oil being a finite resource, all we mean is it will run out. We don't have an endless supply. Crude oil is very important as a source of fuels, such as petrol. Why is it an issue that it takes millions of years to form? Well, if you look at the fact that it's been used for hundreds of years and it took millions of years to build up, we're using it up incredibly quickly. We are going to lose some of the resources that we have absolutely relied on for far too long. A little bit of a recap on some key words here. Crude oil is a mixture of hydrocarbons. You need to know what each of those two words mean. Mixture takes you right the way back to key stage 3, and it has been discussed in earlier videos, in earlier topics, but it's where you've got more than one type of substance and they are together, but they're not chemically combined. Air is a great example of a mixture because it's a mixture of gases. I've got compounds and I've got elements, I've got molecules, I've got atoms, but they are not combined together. My carbon dioxide, my argon, my oxygen, my nitrogen are all separate but mixed together. For hydrocarbon, there is a very specific definition that you need to learn. A substance that is made of carbon and hydrogen is not enough. You need one more word. Only. There is nothing else in there. So let's have a think about how people might write answers in the exam. Here's a few examples of ways that people have written down what a hydrocarbon is. What are our thoughts? Well, my thoughts are quite simple. It's a big red cross next to all of them. We've got some that are too vague. We've got some that might get marks. The bottom one technically is correct, but it's taken far too long. It's not a concise answer, and we should really be aiming for a concise answer. All I needed to add was the word only to here to get the right answer, though. Now let's move on. We're going to look at alkanes. This is a family of hydrocarbons. Remember, that's something that contains only carbon and hydrogen. Have a think about the questions on here, and then we'll review. So this is methane, and the question is, what do we know about it based on what's drawn? Well, we know that it's a covalent molecule. We know it's covalent because carbon and hydrogen are both nonmetals. We also know it's covalent because we represent covalent bonds with sticks between atoms. We know that each methane molecule contains one carbon. We can see it there. And we also know that it contains 4 hydrogen atoms. And because it contains carbon and it contains hydrogen, but it doesn't contain anything else, we also know that it's a hydrocarbon. Now, one of the things you need to know about alkanes is how to name and draw the first 4, but you also need to know the general formula. So, have a think about the questions on here. And what we can see, if I just take the ratio of carbon to hydrogen, I'm going to write those out on the side here, and it's finding a relationship between 1 and 4 that's also true for 2 and 6, 3 and 8, and 4 and 10. So what could I do to the number on the left to become the number on the right that would be the same each time? Well, if I double 1, I get 2, so it's not that. If I double 2, I get 4. Double 3, I get 6. Double 4, I get 8. Well, actually, when I double them, I'm 2 below the final answer. So if I double the number of carbons and then add 2, I've got the number of hydrogens. But how are we going to put that into general formula terms? Well, let's, instead of giving C a number, let's give it the number N. What would the number be for H if I have N Cs? And we've just established that what we need to do is take this number, double it, and add 2. So it becomes Cn H2n plus 2. You will need to remember this. And you will need to use it, and we've got an opportunity to use it here. So see what you can do. So I want to know how many hydrogens there will be, and therefore what the formula of the alkanes will be if it's C5, C10, C22 and C178. Well, for C5, I'm going to double 5 and add 2. It's C5H12. C10, 10 times 2 plus 2, C10H22. If I double 22 and add 2, I get 46. And if I double 178 and add 2, I get 358. Now let's go back and look at these in a bit more detail, because we need to be able to draw them. I've got butane drawn here. We had a table earlier that gave us some information about ethane and propane. How would you draw ethane and propane? So here are the names. The formulae, if you want to pause at this point, if you weren't sure, are C2H6 and C3H8. So to draw them, I need 2 carbons in a chain for ethane, 3 carbons in a chain for propane, covalent bonds represented by sticks, and then I'm going to fill up the remainder of the spaces with hydrogen. You'll remember from the bonding topic that carbons form 4 bonds. So 1, 2, 3, there's the 4th, 1, 2, 3, there's the 4th, and the same is true over on this side. Each carbon has 4 bonds around it. So I've successfully drawn ethane and propane. That takes us to the end of this video. Thank you for listening, and goodbye.